This is going to be a very short video on inverse trig functions, specifically inverse of sine of x, and there'll be others on inverse of cosine of x and inverse of tangent of x. So we have this y equals sine x, and here's a very crude graph. I apologize ahead of time. I don't have my stylus. I'm writing with my fingers, so my handwriting is going to be kind of messy. But here we have a sketch of the graph of y equals sine of x, and you'll notice it is not invertible. And here I'm talking about inverse of sine function. So what are we going to do? So we want to make it invertible, and how are we going to do this? We're going to restrict the domain. We're going to make a smaller domain so that we actually can take an inverse. Because really, ultimately, what we want to be able to do is we want to be able to solve equations like sine of x equals, say, 0.3. We want to be able to solve that. That definitely has solutions, and when we solve equations, we tend to apply inverse functions. Well, we need to have an inverse function to sine of x in order to do that. Okay, so here I'm drawing the graph of y equals sine x again. And so we want to restrict the domain. We want to make a smaller domain so that we can find an inverse function. And the key is here that when we're finding a restricted domain, we want to, number one, make sure when we restrict the domain, we then have an invertible function. And number two, we want to make sure that the range of that domain covers the entire range of the function. So, for example, we want to make a domain that passes a horizontal line test, and we want to make sure the range of that domain goes from -1 to 1. So traditionally, the standard choice is this one, where we restrict the domain of y equals sine x in these two places, and that is from -π/2 to π/2. So there's going to be our restricted domain. I didn't mean to do that. This piece here. And this piece here does pass the vertical line test if that's our only part of our function, and the range is from -1 to 1 still. So if we restrict the domain to -π/2 to π/2, then we have an invertible function. And we're going to call this inverse function arcsin of x or sine of x. Both of these mean the same thing. They're the same function. They are an inverse to sine of x if we restrict the domain of sine of x to -π/2 to π/2. You will see both arcsin of x or sine inverse of x. This one right here does not mean 1 over sine of x. It means the inverse function. I'm going backwards from the output of sine of x to the input of sine of x. So just a few notes about arcsin of x. The domain is from -1 to 1. This is a ratio. It's the ratio of an opposite over a hypotenuse, or I can also think of it as a y-coordinate. It is the output of the sine function. Okay, so the domain of arcsin of x is from -1 to 1. And the range is from -π/2 to π/2. This, the output of arcsin, is an angle. So when you are using these functions, you want to ask yourself, what is the input of arcsin of x and what is the output of arcsin of x? And that might help distinguish what you are doing. So let's just do one example. We want to find arcsin of square root of 2 over 2. So this is going to give us one angle. So remember, the output of arcsin is going to give us an angle between -π/2 and π/2. So only in the first or fourth quadrant, so somewhere in here. Since our input, our ratio, is negative, That means that when you take sine of whatever angle we're taking, we get a negative number. It means we're only going to be in this fourth quadrant. And square root of 2 over 2 should be familiar to you. That is what we get when we have a pi over 4, pi over 4, pi over 2 right triangle, or if you like degrees, 45 degrees, 45 degrees, 90 degrees triangle, an isosceles right triangle. So that's what we get here. This is the ray that has angle measurement negative pi over 4. Okay, that's because when I have this angle of negative pi over 4, that gives me negative square root of 2 over 2 and 1 to get arcsin. If I take sine, I get negative square root of 2 over 2. So my arcsin, the answer is negative pi over 4.